All right, so here we go. We're gonna just continue. The reason I'm doing so many different examples is because there's just a lot of different things that come up, but it's all about applying the basic rules that we learned in the first lesson. So this set of exercises here is going to deal with the power of a product. So when you have two things, two or more things, you could have three, you can have four, you can have many. But if you see parentheses, and you see an exponent at the on the outside, the exponent has to be distributed to everything inside the parentheses. So this 3 right here has to be distributed to both of the um, products inside or the factors inside. Okay, so the way we do that is we multiply. So you're going to have here x 2 multiplied by 3. So 2 multiplied by that 3 on the outside times y to the power of 4 multiplied by that 3, okay? And then we're just gonna do the multiplication here. So you have x to the power of 2 times 3, which is 6, and then y to the power of 4 times 3, which is 12, and that's it. These two, I cannot combine them, right? Same thing here with numbers. So it becomes 2 to the power of 4 times x, and then 2 to the power x to the power of 2 times the 4 on the outside. So the 4 gets the power goes to everything inside of the parentheses. And then we're just going to clean it up. Now 2 to the power of 4, you can go ahead and calculate that. 2 to the power of 4, okay, is 16. Okay, that's my screen. Okay, so that is 16. And then x 2 times 4 is 8. All right. Okay, so when you see negative and you have the powers, you have to be a little careful here because the negative also has to have that square, the 2, this one, the 2. And then you have x to the power of 3 times the 2. Okay. And then you have negative 4 squared. Now, negative 4 squared is the same thing as negative 4 times negative 4, right? You can just put negative 4 squared in the Desmos, but I just want to show you just what all this means. Negative 4 times negative is a positive. 4 times 4 is 16. Or another way you can do this is negative 4 to the power of 2, okay? Which is also 16. What you don't want to do here is not put the negative, okay? If you don't put, sorry, not put the parentheses, because if you don't put the parentheses, it doesn't catch the negative, and then your answer, this is the wrong answer, okay? So the right answer will be negative 4 to the parentheses to the power of 2. Just please, please, please remember that. 16, and then x to the power of 6. And that's it. All right, now here I have 3 things in here. The 2 also gets the 5, so 2 to the 5th power, x to the 2 times 5, and then y to the power of 5. So the 5 is included in everything. So 2 to the 5th power is 2 to the 5th power is 32. And then x to the power 2 times 5 is 10. And then y is to the power of 5. Okay. All right. We're just going to chug along here. Just do all of these. All right. Negative 8 to the power of 2. Same thing, right? Now you have a negative exponent, so make sure you hold that negative, and then you have the 2 here. Hold the negative with the parentheses. Okay. So you have C4 times 2, d to the power of 9 times 2, and then you have negative 8 squared. Negative is a positive. And 8 times 8 is 64. So negative 8 times negative 8 is positive 64. And then 8 And then d to the power of 9 times 2 is 18. All right, negative 5 to the power of 4, m to the power of 6 times 4, and then n to the power of just 4. Okay, negative 5 to the power of 4 is 625, because that's 5 times 5 times 5 times 5. Now, let's take a look at this one. Now, I also have a negative base, but look what happens here. And I'll explain. So negative 3 to the power of the 3 here. Okay. Oh, this pen keeps. All right. And then you have here x to the power of 2 times 3. And then that equals negative 3 cubed. Now, this is the same thing as negative 3 times negative 3 times negative 3, right? And then, which ends up being a negative 27, because negative 3 times negative 3 is positive 9, and then positive 9 times negative 3 is positive times a negative becomes a negative. So just like, alternates. Okay, so that's negative 27. But I mean, oh, I didn't finish this one, my bad. I was, now what do I do? Sorry. Let me rewind. Okay, so this one, let me finish this one. So 625, and then m to the power of 6 times 4 is 24. 6 times 4 is 24 to the power of 24, and then n to the power of just 4. All right, back to this one. So you have here negative 3 squared, which was negative 27. The cubed, which was negative 27. Okay, and then x to the power of 6. All right, so now with fractions, same thing, just make sure that you distribute. And also with fractions, make sure to keep the parentheses as well, because for a fraction as well, the 3 goes to everything, right? The 3 goes, let me break it down just because this is the lesson. I want you guys to see it. So you have here 1/2 to the power of this 3 right here, right? And then you have a to the power of 3 times the 3 on the outside, and then b to the power of 4 times 3, and then times c to the power of 5 times the 3. Okay, now what I want you to see in this one is the 3 has to go, 3 has to go to the 1 and the 2. Okay, let me take off the parentheses in this case. So you have the 1/2, and then the 3. One of the rules we learned is that when you have a fraction, it goes to the top and the bottom. Okay, so again, Desmos takes care of all of that as long as you put it in properly with the parentheses. Okay, and I'll show you the difference. But anyway, let's go ahead and finish everything else off. So you have 3 times 3 is 9, and then b 12, and then c 15. But over here you have 1 cubed, which is 1, over 2 cubed, which is 8. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 8, and then let me just copy all this down. Okay, now I do want to show you how you can handle this in Desmos. So for Desmos here, you're going to do 1 over 2 to the power of 3, and then you'll get a decimal, just turn it back into a fraction to have your answer. I think it should probably work for fractions without a, what do you call it, a parentheses, but let's see. Cubed. Yeah, it still works. But anyway, I always say just use parentheses. It doesn't hurt. Okay. All right. Let me go to the next page. All right. So here's just more of those examples I went over, like with when you have exponents and then your base is a fraction. Just make sure that the exponent gets to the top and bottom, the numerator and the denominator. Okay, so here you have x to the power of 2 times this 4 over here on the outside of your parentheses. And then you have y cubed times you have the 4. Okay, and then you have x. 2 times 4 is 8 over 3 times 4 is 12. All right. 2 squared over 3 squared. 2 times 2 is 4. 3 times 3 is 9. And that's all right. This one, the 2 goes to like a lot of different things. 4 different things actually. The 4, the x to the 7, 6, and the x. I will show you 2 different ways I would probably do this problem, especially when it comes to 48. But so let me do it the first way, where you just distribute everything and then simplify later. So you have 4 squared x to the power of 7 times 2 over 6 squared, and then x squared. Okay. Oh, sorry. Okay, so the 2 gets to everything inside of my parentheses. And then 4 squared is 16. 4 times 4 is 16. And then x to the power of 7 times 2 is 14 over 6 squared. 6 times 6 is 36. And then you have x squared. Now, we still have to simplify this, okay? 16 and 36. I would just, at this point, just throw it in, use Desmos. So you're trying to look for a common factor. Desmos does all that for you. Just plug it in and then reduce it. This is the reduced fraction, decimal, but turn it back into a fraction. So that's 4 over 9. And then for the x, remember when you have a numerator and a denominator and you have the same base, you subtract the exponents. So this is going to be 14 minus 2, which is positive 12. So you have x to the 12. Okay, so that's one way you can do this. Now, another way you can do it is if you want to, you can go ahead and simplify the inside part first and then do the power. So you could do 4 over 6 first. So you can do 4 over 6 first, reduce that, and then you get 2 over 3 inside. And then the x part, 7 minus 1, which is 6. Okay, and then you can go ahead and take the power of everything. Okay, so these two are the same thing. And so this ends up being 2 squared and then x 6 times 2 over 3 squared. So 2 squared is 4, x 6 times 2 is 12 over 3 times 3 squared is 9. Let's see, we get the same answer. Yeah, this one, if you want to just make it like that. Okay. I do want to tell you the answer could look like this: 4x squared over 9, 4x 12 over 9, 4x 12 over 9, or sometimes we just bring the fraction out in the front and then write it like this. Both are fine. All right, so for this one, let's go ahead and do it the first way, where we simplify the inside first and then take the power. So 5 over 10, that's 1/2. 5 over 10 is going to be 1/2 inside of the parentheses. I'm going to keep the parentheses. All right, 6 minus 4 is x to the power of, you know what, when I'm doing a fraction, let me go ahead and make this, okay, x to the power of 2. 6 minus 4 is 2. And then remember there's a 1 here. 2 minus 1 is 1. So y to the first power. And then this whole thing gets raised to the second power. Okay? And so you have 1 squared, which is just 1. I don't have to write it because I have other things in here. 2 times 2 is 4. You multiply the exponents when you're raising a power to a power. And then y to the power of 2 over 2 squared. 2 times 2 is 4. Okay? That's one way to do it. I will quickly do the other way as well, just so you have it, in your notes, since I'm introducing all this to you right now for the first time. Here's another way you can do it. Sometimes it's easier just when you have everything, sorted out. So 5 squared x 6 times 2, and then y 2 times 2 over 10 squared x 4 times the 2, and then y 2. Okay, so 5 squared, 25. 10 squared is 10 times 10, which is 100. And then I have everything else here. Let's go ahead and clean this up a little bit. So 25 over 100, you can reduce that down to 1 over 4. Okay. Yeah, 1 over 4. And then 12 minus 8 is, 12 minus 8 is 4. My mind just went blank. Yeah, 4. And then 4 minus 2 is 2. And again, when you have the 1 in the top, you don't have to write it because 1 times anything is itself. So there you go. All right, now this one. Hopefully, you made it this far. This one. I will show you, I will straight go into like how I would do this problem. Whenever you see something, when you have a fraction inside of your parentheses and you see a negative exponent, just flip everything and then do the problem, okay? Here's what I mean. So for this one, what I'm going to do here is, I know that the negative, one of the rules is it moves, right? The negative on the top goes on the bottom, the negative on the bottom goes on the top. Even if you have negatives on the inside, this is how I would handle this problem. I would put everything in the denominator up top, and then everything in the numerator in the bottom, and then turn this -3 into a +3. These two are the same thing. The negative has that much power. The negative exponent has that much power to flip everything upside down, okay? And then you can continue on, okay? It's much better. I don't even going to do the other way where I distribute the negative, everything. It's just too many negatives. Okay, just start with this. All right, and then let's just continue. 3 cubed, y 2 times 3, and then 2 cubed, and then y 5 times 3, okay? And then 3 cubed is 27. 3 times 3 times 3 is 27. And then y 6, 2 cubed is 8. 2 times 2 times 2 is 8. And then 5 times 3 is 15. You can try to reduce 27 over 8, but it won't. 27 over 8, it's already like the lowest reduced fraction there is, okay? And then that's it. Well, that's not it. I can simplify the y's. Now, when you subtract, so you just numerator subtract the denominator, right? 6 minus 15, it's a -9, okay? So you could put -9 at the top and then move it to the bottom, or just know that this will end up being the -9, you turn it into positive by moving it to the denominator like that. Or another way you can think about it, which is much better, is like you take off y to the 6 in the numerator, take out y to the 6 in the denominator. So if you take out 6 away from the 15 that you have down there, you have 9 left over, okay? So that's how I would do it, honestly. Okay, and that's that. All right, you guys. So I'm thinking if I should do a new video Yeah, I'll do a new video for these 4 problems. Now, before I stop this video, I just want to tell you, like on the test in SOL, you'll see something like this, but it's okay as long as you apply all the rules that we talked about, the laws of exponents, um, and this will work out. All right. See you in the next video.